In this video, we will go over graphical limits. We'll read the left-hand limit, right-hand limit, and when they are the same, we will say that the limit exists and we will find that value. So if the left-hand limit and the right-hand limit does not match, I think we talked about that in class. Let's say if the left-hand or the right-hand limit does not exist, or if the right-hand and the left-hand limit exist but they are different, then we're going to have to tell them that the limit does not exist. So we'll look at some examples given a graph right here, okay? And I'll ask you to come up with a picture that looks like this for our week 1 problem. I'll just ask you to be creative and come up with a graph that has a couple of these uh, conditions. So we'll take a look at that in another video, but in this video, let's talk about reading graphical limits. So here's the first one. I have limit of f of x as x approaches. Now this red part is important. This is telling us what to read, okay, where to go. So this is asking us as x approaches what number? -4. As x approaches -4 from what? From left. That minus sign right there, that means we're approaching -4 from its left. So I'm going to go to the graph and find -4. Here is -4 right here. So we need to start somewhere on the left of this -4, okay? So it doesn't matter, just to the left of -4 somewhere, and then go to -4, okay? Follow the graph from the left. And what we see is as we get to -4, we are at this point right here, this point right here. All you need to do is read its y coordinate. What is the function value? It's right above 5, so it must be 6. So the left-hand limit is 6. So this is just picture reading, really. But we need to understand what this arrow notation is giving us, okay? So let's try another one. I'm going to go ahead and do the second one, part B. It says limit of f of x as x approaches what number again? -4 from its what side? Right. Oh, I have to zoom out a little bit. Because of that plus sign, this time it's telling us to start somewhere on the right of -4 and go to -4. So let's try that. So -4 is right there. So I have to start somewhere on the right. This is to the right. I'm going to go to -4, go to -4, go to -4. And right here, we have a point. Okay? So if you look at the y value of that point, this is 1 below 5, so the y coordinate must be 4. The function value must be 4. So the right-hand limit is actually 4. Now look, from the left and from the right, they're different. So they're not the same. So we can go ahead and say something like this. Since the left-hand limit as x approaches, let me zoom in, x approaches -4 from the left is not the same as limit of f of x as x approaches -4 from the right. What we can say is that the general limit as x approaches -4 does not exist because they are not the same. Oopsie daisies, wrong word. Exist. Okay, so I think that's actually part C though. Yeah, that's what they were asking down here. So you notice they don't have a symbol right here. That's the general limit from both sides. Because they were, one of the answer was 6, the other one was 4. They are not the same. We have to just say does not exist. And the reason is right there. Since the left-hand limit and the right-hand limit are not the same, the general limit just does not exist. All right, so let's look at, well, what's this? F of -4. So this is just evaluating function, okay? So this is not limit. We're just trying to find a closed circle at x equals -4. What they're asking is, what is the y value for x equals -4? Let's go find it, okay? When x is -4, where is the y value at? So now we got a problem though. We have 2 points. So at x equals -4, we have a closed circle and an open circle. So which one should you go with? You have to go with the closed circle for the function value, okay? So we can say that f of -4 is equal to 6 because that's a closed circle, okay? So the last part down here, f of -4 equals 6, okay? We will talk about something called continuity in the next section. Hold on a second, I'm getting scared. Is it this section? Yeah, I think it's gonna be the next section. Yep. We'll talk about continuity later. And for a function to be continuous, so I'm giving you a little bit of preview, the limit and its function value has to be the same. As you can see, the limit didn't even exist, right? But the function value is at 6. So this function is not continuous at -4. And in pre-calc, we talked about if you cannot graph this function or graph without lifting a pencil, I mean, we're going to have to jump down here, right? This function is not continuous. But we'll talk about continuity in another lesson, okay? All right, let me go to the second page now. And working with the same picture, but at a different point. So first one is asking us to find the limit as x approaches. Now this is not -8, as you know, okay? As x approaches what number? 8 from the left. Okay, so you start somewhere on the left side of +8 and then try to go to 8 and see where the graph is going. Okay, so let's take a look. So where is 8, by the way? So this is 5, this is 6, this is 7, this is 8. Okay, so this is 8. I'm going to start somewhere on the left of 8. So if I'm just somewhere on the left of 8, trying to go to 8. Oh, look, I'm going to this point, that open circle. I'm trying to get really, really close to that open circle, right? And that value is 4. That value is 4. I mean, we don't really have a value there, but it's probably getting like really close to something like 4.000001. And the next number could be like 4.000001. We're getting really close to 4 from above, right? Okay, so by just reading the graph from the left, we're going to that open circle. So the y value is, the limit is 4. Now let's look at the right-hand limit this time. As you approach, as x approaches, what number? +8 from the right. Let's see where we're going, okay? So start somewhere on the right side of this graph. Go to 8. And you know what? They're going to the same place. Both of them are going to this open circle, aren't they? So the number is going to be the same. It's going to be 4. It's going to be 4. So look, the left-hand limit and the right-hand limit matches at x equals 8, right? Yay, they are the same. Okay, I'll say that they are the same. And that's very good, because if they are the same, the general limit at 8 exists, and that is simply the same as the left-hand limit and the right-hand limit, because both the left-hand limit and the right-hand limit at x equals 8 is 4, the general limit at x equals 8, or x approaches 8, is 4. Okay, and this is what theorem 1 was talking about when you first saw this box with all these symbols. But in this case, the limit is 8 because both the left-hand limit and the right-hand limit came out to be 8. Hold on a second, was that the number? No, I'm sorry, that was 4. All right, I'll just go down. All right, I think I have one more. This part, I'm asking you to evaluate f of 8. Okay, so I'm asking you, what is the y value when x equals 8? Okay, go find a closed circle or read a graph, right? But remember when we were looking at those limit problems, I thought we saw an open circle. You see, at x equals 8, we have an open circle. So unfortunately, f is not defined at x equals 8. So the function is not defined at x equals 8. We have a hole here. We have an open circle here. So I'm going to have to say, I like to say undefined. But I've seen some students saying f of 8 does not exist. And that's not wrong. Well, I like to still say this is undefined. All right. And remember a little preview of continuity. If the limit and its function values are the same, then the function is continuous. But as you can see, this function is not continuous at x equals 8 because we have a hole here. Okay? Alrighty. So really the last part I. It says, oh, okay, they're not asking us for the left-hand limit or the right-hand limit. They're just asking us to find the limit as x approaches 5. So what we need to check is it the same approaching from the left, and is it the same approaching from the right? So let's go look at that important point 5, x equals 5. All right, x equals 5 is right here. Okay, so from the left of 5, I'm going to this point, right? From the right of 5, I'm also going to that point. It's the same. So what is the y-coordinate of this special point? That is 5, 6, and 7. So I'm going to go ahead and tell them, I'm going to give them a long answer, okay? We'll say that the limit of f of x as x approaches 5 is 7 because, let's practice our limit notation. Limit of f of x as x approaches 5 from the left equals limit of big F of x as x approaches the same number 5 from the right are both equal to 7 because the left hand limit equals the right hand limit. We get to say that the limit exists, the general limit exists, and that's the same as that number. Okay, so hopefully these two sets of examples are making sense. And now I'm going to ask you to try. Okay, I'll make this into a I'm going to grade it, but it's not going to count against your grade because this is a practice grade. I'll ask you to try this set. Okay, this is page 5, and I already made this into a small Canvas quiz. Okay, you will submit your answers for A through L on Canvas, and it's going to auto-grade it. You can take it as many times as you want until you get all of them right, but that's just a practice. So I want you to try it, but it's gonna be a 0-point assignment. Okay, just want you to try it. Okay, I'm gonna end this video, and I'm gonna come back and talk about the limits involving infinity in a separate video.